Hello, it's Mr. Gold, and this is your application video for learning target. I can calculate conditional probabilities in different real-world contexts. So in the warm-up, it said, at Energy Tech, the students fill a small baby pool with water and painted ducks. The ducks have the numbers 1 through 30 on them, and the game is simple. You pick up a duck and you win a prize. Now, the game has changed for our application. For application, when you pick a duck, you need to either get a duck that has a prime number or an odd number. So, what are our chances? So let's go ahead and take a look at the numbers. So I went ahead and I wrote out all the numbers that are odd, all the numbers that are prime, between 1 and 30. Then, I circled the ones that are the same. So this way I know that's an odd and a prime number, right? Then what I did was I went up to my Venn diagram, sorry, and I wrote the ones that are only prime here, which is 2, only odd, and then the ones that are both prime and odd. So now when we're trying to figure out the probability, we're not just going to add that number and those numbers and say, oh, it's that over 30, right? Because it's 30 total numbers. But instead, we're going to look at how many numbers are prime, how many numbers are odd. Then we're going to subtract the intersection here so that we only count each number once. So let's go ahead and do that. So when we counted prime numbers, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 out of 30 that are prime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Excuse me again. 15 that are odd, because we have 15 odd numbers out of 30, and now we'll add them together. So we have 25 over 30, and now we're going to subtract this intersection here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to subtract 9 out of 30, and that is going to give us 16 out of 30. So how do we double check this? We go up here and we say, how many numbers do we have? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 numbers here and 16 here, right? 10 out of 30 we had were prime. 15 out of 30 we had were odd. We added them together. We got 25 out of 30. Then we subtracted the 9 that were the same in the intersection. We got 16 out of 30. For the second part of the question, it said, what's the difference between the probability of prime or an odd number, which is what we did here, and prime number that is also an odd number? So that is when we look just at the intersection, and we're going to look at just what we have here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 in the intersection. So that's the difference, right? If it has to be prime and odd, it's going to be 9 over 30. That's prime and odd. And if it is 16 out of 30, it will be prime or odd. Remembering that it can be both an odd prime number or just a prime number, but we have to make sure that when we count, we are looking at both sides and then we take out the intersection. All right? If you have any questions about that, feel free to reach out to Ms. Coles or myself. Otherwise, hope you guys are having a good day. Gold out.